prove or disprove, by providing a counterexample, the statement here. For any three sequences, if one of them is the sum of the other two, okay, then it is impossible for exactly two of these series, we've got the three series adding up the three sequences, to be convergent. Okay, so what they're saying is, I don't care if exactly one is convergent, I don't care if they're all divergent, so 0 of them being convergent, and maybe there's some way for all three of them to be convergent, but it is impossible that two of them, maybe the AN and the BN are convergent, but the CNs aren't. That's the idea. So we can either prove this statement using theory that we know, or we might disprove it by finding a counterexample. What would that look like? Well, you'd be able to give me an AN sequence, a BN sequence, and a CN sequence, so that the ANs were BN plus CN, okay, and exactly two, I don't know which two, but exactly two of these series converged and the third one diverged. Because then that would have exactly two of these series be convergent. So we can play around with this a little bit, but it's a good idea to try and develop sort of a gut reaction. Does this seem like a sensible statement? Or does this seem a little too restrictive? You know, why are you messing about with 2? Why is 2 the issue? Okay? And why are we asking about this relationship? AN is BN plus CN. Okay? So, well, we might start one way or the other. We might start trying to find some sequences that work like this. In fact, you only really need to find 2 of them, because the third one has to be the sum of the other 2. Right? So we might try that, or we might say, you know what, I think this might be right. Let me try and write this up. So I think it might be right, and here's why. We know that there's theory involving the sum of series. Okay. So here's my attempt at a proof. We're going to start it. It's always okay if while doing a proof you realize, hey, this isn't working, this is taking too long, this is too complicated, and you either start again, or you say, well, you know what, maybe my gut reaction was wrong. It happens all the time in math. Okay? It happens to me more than I'd like to admit. And so maybe I need to try the other way. Maybe I need to try and disprove this result. Or you might start trying to find sequences to prove this wrong, and say, you know what, this is really hard, it's not working out. Let me try it by proving it. Okay? So, I'm going to say something like, let's prove that it is impossible specifically, here's my plan. We'll show that if 2 of the series, I'm not going to say which 2, but if 2 of them converge, the third one does as well. Okay? So that's going to be my plan. Okay. So there's going to be sort of 2 cases here. Right? Owing to the relationship between the ANs, the BNs, and the CNs. Okay? We might talk about the BNs and the CNs, and then show that the sum for the ANs also converges. Or maybe the AN and the BN, they converge, and we'll have to show that the CNs converge. Okay? You might say, well, hold on, how come you're not doing the ANs and the CNs converge, and then concluding that the BN, well, because it's just this case with some of the sequences renamed. Okay? So there's 2 cases. So case 1. Suppose, and we'll include all our little indices and subscripts and everything. So suppose these converge. Okay? Well, we know the AN sequence is just BN plus CN. Okay? This is true for all n. Each term in the A sequence is the sum of the two corresponding terms in the B and C sequences. So what we want to do, starting at 1, is show that the sum of the ANs converges. Okay, but the ANs, we do know something about them. We do know it's the BNs plus the CNs. Okay. But since the sum of the BNs and the sum of the CNs converge, we have a result that says, well, if you add them up and try and do that summation, then it'll also converge. Right? So we'll say, therefore, the sum of the ANs converges. Okay? So if two of them converge, the third one does as well. You might say, great, so we're done, right? Well, no. What we have just shown is that if the two sequences, or the two series corresponding to the sequences that add to the third one, converge, then the third one, the one that's made by adding, also converges. Okay. We have not shown that if the sum and one of the sum and sequences, we might call them, converge, then the other sum and sequence converges. So that's a second case. Okay. Theory is such a fun, subtle thing. Okay. So let's suppose, well, that was a terrible sigma. Let's suppose the sum of the ANs and the sum of the BNs converge. Okay. Now we know that the ANs are the BNs plus the CNs, but we can isolate this, okay, rearrange it and say, well, the CNs must just be the ANs minus the BNs. Okay. Now, just like we had a result that says, well, if you're working with the sum of two sequences, and individually those sequences series converge, and then the new series must converge. Well, same sort of thing works with differences. Okay, so the CNs are just the ANs minus the BNs. But since the sum of the ANs and the sum of the BNs converge, we know the sum of their difference converges too. So the sum of the CNs converges as desired. So, what have we shown? Well, these are our two cases. Let's say, in conclusion, because I'd like to summarize for whoever might be reading this. In conclusion, if two of those series converge, the third has to. So the third must converge as well. So it is impossible to have exactly two of those series converge. If I had exactly two of them converge, then that means two converge and the third one doesn't. But we've shown if two of them converge, the third one does as well. Right? So that does actually prove the result.